Thank you for having us here today.
Thank you.
We really appreciate you taking your time out. So, the whole reason we are here today is to educate ourselves on the moon cycle, the moon rise, essentially the phases of the moon.
Mm-hmm.
So, what we would like to know from you is how does the moon rise and the moon set works?
So for us, the moon rise and the moon set is kind of dependent on when the moon comes up from the sunrise or from the horizon, and then kind of comes down and sets on the horizon, kind of like how the sun does, where the sun rises and then eventually sets during the day. And the moon follows the same process simply because the Earth is rotating, right?
Right.
We're not simply just standing still and everything is rotating around us. The Earth is rotating and everything else is rotating, which causes those kind of things to rise and set. Like the stars, they all rise and set because the Earth is rotating on itself, on its own axis.
So just like the sun. So for example, if I'm in July,
Mm-hmm.
the sun would set and rise, for a very long period. So we have more daylight.
Mm-hmm.
Right? So sun could be setting at like 9 o'clock in the evening,
Mm-hmm.
or rising at like 4 in the morning.
Mm-hmm.
So I'm assuming the same applies to the moon as well. If it's different time of the year, it would rise and set at different times.
Yes, that is correct. And that is mainly having to do with the fact that the Earth is kind of tilted a little bit on its own axis,
Yeah.
which causes the seasons. And that in itself causes why the sun rises at different times of the day during the whole year. And that is why the moon would rise at different times of the day as well.
So for example, if somebody wanted to spot the moon and visibly see it being born, or whatever the term is,
Mm-hmm.
it being born, it could very well differ different times of the year. So in January, you probably would be able to see it better, or vice versa. In summer, you might be able to see not as good. How does that apply to visibility of the moon?
Yeah, the visibility of the moon, it would change because the moon is also visible during the day. So you would have to check when the moon rises and it sets on that day to see if it is visible. So for some people, if they're looking for the moon in the night on a certain day of the year, and it turns out that the moon is already set by that point, then you won't see it during the night, and you might be a little bit confused when in the while it's just actually been in the day during that time.
Right, so probably not a good idea to be looking for a moon when it is already set.
Yes, exactly. You don't
That's
want to look for it if it's not going to be there.
So how do you determine the moon has set or risen?
There's a lot of things you can look online, different calendars you can check, where a lot of people measure this quite accurately to the minute almost, and you can check these moon rises and these moon sets just based on how it is in the sky. So like for the sun rises in the east and sets in the west. And very similar to that, the moon rises in the east and sets in the west, and that is because the Earth is rotating. And so if you're trying to figure out if the moon has already risen and is about to set, you can see where kind of it is in the sky, if it's towards the west or the east.
Interesting. So essentially, somebody who's in Far East, somewhere in Australia, and if they've seen the moon, for example, somebody in North America, can it be the same moon for them, or essentially they're seeing the same moon,
Mm-hmm.
but can it be different moonrise or a newborn moon on a different day? Could it be 24-hour difference? Could be a 48-hour difference between the two countries?
So the moon itself would have the same phase depending on if you're in Australia or North America. But for the moon set and the moon rise, I believe they would change depending on where your location is, because the moon itself is rotating as well around the Earth. However, I don't expect it to be that much different,
Right.
but the moon phase itself would be the same even if you were in North America or Australia.
Right. And does the moon rotate?
Yes, that is a big misconception on if the moon actually does rotate, because in our eyes, the moon has the same face each time we look at it, and in actuality, the moon does rotate, but it takes about 27 to 28 days for it to rotate on its own axis, and that's about the same time that it goes around the Earth. So in reality, the moon is what is considered tidally locked to the Earth, so that it rotates at the same speed as Earth does. So we always see the same side of the moon.
Oh, really interesting. And now, is that true that moon was at one time part of Earth, and now it's kind of tidally tied to Earth?
Yeah, so there is a theory. Obviously, we can't say definitively what happened millions of years ago, but there is a theory that the moon did used to become Earth, and that there must have been some big collision with another planetary body that caused so much of the Earth to break up that it was able to create this moon outside of the Earth. Now, one reason we know this is that different rocks that were brought back seem to contain different information that, or sorry, the same information that you would see here on Earth. And the only way that would the same kind of rocks would form was if they were in the same location before.
Right.
Yeah.
And does that apply to all the other planets, the same thing then? Because they all have they have not just one moon, few of them have a few different moons.
Yeah, like Jupiter and Saturn, they have so many moons because they're so big in themselves. However, I think this was something that's very unique to Earth itself. A lot of moons, they might have been grabbed, like let's say an asteroid was whizzing by a planet and the planet was so strong it was able to grab that and then create it as its moon.
Right.
Those kind of cases happen for Saturn. Saturn has its big rings around the planet. Moons are actually created in those rings after so many times, and there's people out there that actually study those kind of things. Moonlets, I believe they're called.
Again, so the moon is tied to the Earth, gravitational pull. Is that essentially the Earth's gravity?
Yes, yes, that's essentially it. Is Earth's gravity is be able to hold the moon in its place, and that's why we have it continuously rotating around, and that's why we have the planets rotating around the sun, is because the sun has so much gravity that it's able to keep the planets in the rotational pull.
So if I got you right, the moon cycle is 28 days?
Correct, yes.
So if the month is 31 days, how does that play for a calendar that's dependent on a moon cycle?
It does kind of go here and there depending on when the moon cycle starts for the 28 days. February is a great month where it is exactly 28 days, so the moon cycle is quite consistent with that month. However, the days that the moon's phases start on actually do change here and there, like 1 to 2 days on either side. So it can be confusing to have a calendar that is not really exactly with the moon cycle. However, the Gregorian calendar that we use today was actually originally built on the moon cycle, interestingly enough. And I think it was just days here and there that they decided to change up that did not really line up, unfortunately.
And I'm assuming that was to conclude the 365 days.
I believe
of
so,
the year.
yes.
Okay, and also the visibility of the moon. I know because of the pollution in Earth, because of climate change and all those things, I'm sure that affects visibility of the moon, visibility of the sun as well, right? So, what do you think? How much of a play does it have? For example, we're blessed in Canada; we don't have issue with pollution, but in a country where it's very polluted, for example, China or India, for them it could be quite difficult to spot a moon.
Yes, I agree.
So if you were to look at it from your perspective, if a country really depended on sighting the moon for their new month, what would they do if coming in the 50 years from now, they were not able to see the moon because of the pollution? What would be their solution in your mind?
So for the pollution for seeing the moon itself, it probably will get quite intense as time goes on, as we're kind of seeing with greenhouse gases and that kind of thing. And even clouds can prohibit us seeing the moon itself, right, which can be a problem if we get a very cloudy day or night when we are trying to look at the moon. In my opinion, we have so many people out there putting together calendars for the lunar cycle, and we even observe the moon outside of Earth. So like up above the atmosphere, we have orbiters up there that can even take a look at the moon and all that kind of stuff. And in my opinion, if you were curious about trying to maintain the moon and knowing the cycle and all that kind of stuff, you might want to turn to those kind of things to be able to help you, some kind of calendar that people can reproduce, because people can reproduce calendars that are quite well into the future on what the lunar cycle will be.
So that would apply just exactly like the way a calendar could be made for a sun cycle. Exactly the same thing can be made for moon.
Exactly.
And how accurate would that be, for example, throughout the year? if you were to print one?
It would be accurate within a couple of hours almost, between moonrise and moonset.
Now, what's the best way to spot a moon? I mean, one is through the naked eye. The other is the telescope. Are there any other instruments?
So for instruments looking at the moon, binoculars are actually a really great way to do it, because the moon can be so bright to your eye that it can almost be blinding if you're looking at it through a telescope, that most astronomers don't look at the full moon through a telescope because it's quite bright. But binoculars would be a great way for people to be able to see the moon, especially a new moon that's very faint in the sky. You would probably be able to still see it with binoculars.
So are you saying even a newborn moon with the crescent, it's best to see it with binoculars?
Binoculars, yeah.
Really interesting. Did
Yeah.
you know that? We thought it was the best. The equipment was the telescope.
Me too.
Did you mention the other way to calculate or spot the moon cycle is to go out of the orbit?
Looking at the moon from outside of the Earth, I'm talking like even outside of its atmosphere, like as an orbiter above the planet, because what you could do was you could measure how long it takes the moon to rotate around the Earth, and then simply divide that into 4 to get your lunar cycle, since that's technically how it kind of works, where it's rotating around the Earth, and those are kind of the different cycling depending on when the sun is shining on the moon.
Right.
So if you had an orbiter above the planet, above its atmosphere, you could at least measure how the moon rotates around the Earth and measure the time, such as days, that it would take for it to rotate fully.
Challenge for some people is that they are able to see the moon in the same community. We're talking in the same city. So if we're in Toronto, some people are able to see the moon in Toronto. Meanwhile, in Markham, they can't see the moon. How is that? Is that just a simple error of spotting the moon?
For people not to see the moon in the same location, there has to be some kind of error associated with that, because scientifically I would consider that impossible unless there were clouds in the way. So like, for example, if it's not cloudy in Toronto and they can see the moon, but in Markham or wherever it is cloudy and they can't see the moon, that might be a reason why they can't. But for all around the Earth, everyone sees the same phase of the moon at that same time. So unfortunately, I don't see how it could happen where people in the same region could see the moon and not see the moon.
So if somebody was in Australia, they spotted the moon, and they send me a text message, hey, in a few hours you should be able to spot this as well. Would that be true?
Yeah, people in Australia definitely would be able to see the moon, as well as people in North America. It'd be the same phase. It just would depend on its moon rise and its moon set. And one thing you have to think about too is that in Australia, you're below the equator. The moon would actually be upside down than what you're used to here in North America.
And what about operating the telescope? Because I've tried doing it. I got it from my nieces and nephew. We put it in the backyard, and I couldn't even get the moon on the damn thing. It was so difficult to gauge that. Can you?
Yeah, so operating telescope can be fun in some cases. It can be very frustrating if you don't know what you're doing. And there's so many resources online for you to look at. The Royal Astronomical Society of Canada, they offer a lot of things for the public that can teach you how to use telescopes, what you want to look for. Most telescopes nowadays also offer onboard computers that can actually manually move it for you to an object, and then you can basically look in the eyepiece and it will be almost right there. So if you're willing to spend even more money, you can get ones that have computer programs that will actually move it for you, which makes it a lot easier for the average person.
So essentially, given the moon phases and moon cycle, if you're just pointing at that telescope in a complete wrong direction and you're looking for a newborn moon, which is not even up there, you could be pointing at a completely wrong direction.
Yeah, it's hard to tell if you are pointing in the right direction towards a new moon, just because it is faint. And if you don't quite know what you're doing, it might be a little confusing. And that's why there are different resources online you can check out for that.
So at the end of the day, if somebody's using that telescope to spot the new moon, at the end of the day, they do have to rely on the calculation of where the moon would be anyways.
Pretty much, yeah. So for looking even for astronomical objects that aren't as big as the moon, we have to use on a lot of calculations to know where they are in the sky. We have actually different coordinate systems that we use to find those objects that translates it well for the telescope.
Right.
Yeah.
So then it almost defeats the purpose of using the telescope, because if you're using the calculation anyways to point it at that direction,
For the moon itself, I would recommend a mixture between calculations and like binoculars of being able to see it for sure. Just because it is so big, you could probably see it with binoculars rather than a telescope.
Right.
Yeah, so right now we are in February. It's just finished a cycle, so it's about to start at a new moon. And if you actually look here, as the new moon started, you can see a crescent on this side of the moon. And this is in February. And if you take a look down here, you can see that this, at this point, is when the moon is either approaching its furthest away point or it's at its closest point. And so as we continue along, you can see how there's one crescent here. You can tell which crescent is dependent on which side because you're approaching the half of the moon. That's how you know that the moon was born or new, and then it's approaching its cycle, is that it's at a half moon. Now, this is still in February, right? So we continue along, and there's a full moon there, ending towards it's about February 18th right now. And as we continue on, you can see how the other side of the moon is getting dark with the shadow coming up. So you can tell that is the ending crescent here because the moon was already half, and now it's starting that shadow enveloping the entire moon. So you do have a start crescent and an end crescent. So that might be perhaps what one of the confusion is on if it's a new moon or not.
Right.
So here we're at March 2nd, and you're at your other crescent here right before a new moon.
Wow. Okay. That's something very, very new for me too. That's cool. All right, this is good info. And this percentage here, so if it's at 1%, it means we have a new.
Yes, exactly.
Or,
And
yeah,
new
new
moon.
bo- new-
Yeah,
new
so
moon.
this is about 14-15% lit right now.
And you're saying that this can be essentially all calculated.
Yes, it can.
So we can say on a safe side, if the moon is based on calculation, if it's at say at 2%, is guaranteed to be visible,
Yes, pretty much.
depending on clear sky and all those factors.
Mhm.
Okay.